You can have a strong acid with a strong base. The equivalence point will have a pH of 7, yes. You can also have a strong base titrated with a strong acid. Your pH is still going to be 7. That's because, okay, strong acids are usually abbreviated HX. At the neutral point, there's no H pluses or OH minuses. The H pluses and the OH minuses have all come together to form water. And then you also have left over the conjugate base of a strong acid, which we know is neutral. When you have a strong base, at the equivalency point, all of the OH has been consumed by the H plus from the strong acid to form water. There's no H pluses or OH minuses. All that is left over is the conjugate acid of a weak base. And the conjugate acid of a weak base, as we just discussed, is neutral. This is why the pH is 7 when you titrate strong acids and strong bases together, whichever way you do it. Now let's go to our next possibilities. You can titrate a weak acid, usually abbreviated HA, with a strong base. And notice, okay, so weak acids dissociate a little bit. You're going to see a little jump right here. That little jump right there is when the free H pluses are consumed. The free H pluses are consumed, and then at some point in time, we have to start pulling H pluses off the weak acid. Remember, this point here is when the pH is equal to the pKa. This right here is the equivalence point, just like in our others. But at the equivalence point, you've added enough OH to pull off all of the H pluses. So at the equivalence point, you will have, again, water. But this time, at the equivalence point, I have the conjugate base of a weak acid, which is a weak base. So at the equivalence point, my pH is going to be greater than 7 because I have a weak base in solution. My next one is if I have a weak base titrated with a strong acid. Again, here's where we're adding H pluses, and H pluses are going to consume the free OH minuses. Then we get to a point where all the free OH minuses have been consumed, and we have to pluck OHs from our weak base. This is the half of equivalence point, and this is where the POH is equal to the pKb. And remember, we've already been doing all these weak acid, weak base problems, getting Ka from Kb, all that kind of stuff. At the equivalence point here, you have no more H pluses or OH minuses. All the OH minuses have been consumed by exactly the right amount of H pluses to produce water. And then we also have the weak base. The conjugate acid of the weak base. So we know that there's no base left over. All we're left with is the conjugate acid at the equivalence point. Therefore, at the equivalence point, the pH is going to be less than 7 because in solution, all we have left is the conjugate acid of a weak base. This is the reason why our pHs vary depending on what you're titrating with. And common misconception, the only titrations that will have an equivalence point with a pH of 7 are going to be strong acid and strong base together.